most of the time go quite well together. So, since we're all programmers here, is there a way to automate the page layout? Or maybe even the design of a whole book? That would be good. Well, we have, of course, desktop publishing. But it's not a solution, because it reduces fixed templates, which are boring, because they are all exactly the same. And some of them are even quite bad. They're not following real layout rules. Or they, on the other side, allow you so much freedom that, again, you start doing things on your own, and probably doing it bad unless you are a trained layout or typesetter. And also, most of the desktop publishing programs, they use a closed internal format. It's very difficult to get inside the program. It's very difficult to automate it. As you probably can do it just through the command line and back quotes, but most of the time the file format as such is not published. Because desktop publishing, it's all about just moving blocks and things on your screen, and not doing that automatically from externally from the program. So, is there a solution? Yes. Otherwise, I would not ask the question. And this solution, it might surprise you, even predates all these graphical desktop publishing programs. So, what? You have a solution which is older than the graphical PC? Yes, and by far. And the solution is called TEC, written like this. Big T, E, and the X is not X, but the Greek key, TEC. TEC is a typesetting system and a programming language, really, designed and written by Donald Knuth in 1978. It's really old. And indeed, this is the Donald Knuth, well known from his books, The Art of Computer Programming. And let's all pray and hope that he lives to be 120 years old and ever gets time to finish this book, because I only got the 3 first volumes, you see. It's quite an investment. And 4 more volumes have to follow. But they're not yet there. And it's already, I think, 75 or 80, or it's quite old. So we have to live another 40 years to make, otherwise my investment is lost. So please pray that he lives very long. The reason why Professor Knuth, who is a professor of mathematics, invented the TEC language was that at a certain moment his publisher said, Professor, we have now an electronic typesetting system, very modern, new with computers and things like that. Oh yeah, nice, very nice. So he started giving them probably these very big floppies, on which you could have one chapter of his book on a whole floppy, giving them to the publisher, and then getting the proofs back. And they were ugly. They were dead ugly. All the mathematical formula were incomprehensible. And he went back and I said, look, before you had an old man who, with little letters, put them together, so the formulas came out all nice. I'm retired. I got a computer now. Yeah, but look at this formula. It's bad. It's terrible. It's not the way it should be. Yeah. Can't help. Blame the computer. Sorry. So there was no solution at that moment, unless you are Professor Donald Knuth. So he took a sabbatical, and he gave the world TEC. Now he wouldn't be a professor, and he says TEC is intended for the creation of beautiful books, and especially for books that contain a lot of mathematics. He's a professor of mathematics after all. But really, TEC, it's a macro processing language. It's Turing complete, so it's a full-blown programming language. And as such, TEC does know nothing about layouting, it's just microprocessing. So you have to have a set of macros which makes it into your typesetting system. These are called the plain TEC macros, which is, it starts automatically when you start TEC, it loads the plain macros. That's the way it starts. I don't think anyone else uses TEC for anything other than typesetting. Maybe just for fun that you look at. I see a few people who've written a game in TEC. Or tic-tac-toe or something. It worked. A little bit of artificial intelligence there, but it's a Turing complete language. But really, everybody uses it for typesetting. But plain text, it goes like this. This is a plain text example. It starts by saying H rule, everything which has the backslash is a command. Remember, this is 1978. Computers had very few memory, very slow processors, not powerful at all. So the parsing of language has to be simple. So every command starts with a backslash. That's easy. And the command goes on until it gets something which is not an ASCII letter, A to Z. Even some exceptions are there, like not the ampersand, the at sign. That also stops a sequence of characters to make a command. So it's quite easy to parse it. Probably the parsing is like 5 lines or something. Originally it was written in Pascal. We don't know that. So the horizontal rule, which is a line, length of your page, then it skips 1 inch vertically. It centers in bold format a short story, and it skips 6 points. Point is the usual measure for typesetting. I think you have 72 points in 1 inch. But European points are a little bit different than American points. Then you center in slanted text, which is not like italics. The difference between slanted, which is just normal text, which is kiligo, by AU Tor, and then you skip half centimeter, so you can use all kinds of different measures in between. And then you have once upon a time, etc., etc. This here produces O with an umlaut on it, a small O with an umlaut on it. This says that on the C you have the little foot, the CCD, and it goes on like that. So yes, this produces quite nice text, but it does not automate the layout yet. And again, you say eject. Eject means push out the page. Once it sees this, it starts putting everything on the page. Until then, it's very lazy. It doesn't do any work until it sees eject. So you can do a lot of things and go back and forth and then eject, and then the page is shipped out. But it's does things like typesetting mathematical formula. Try to do that in Word, unless you have a lot of extra modules and extensions. But it doesn't have to be mathematical formula. It can be very calligraphic as well. And anything in between both. But you still have to think about the layout yourself. Yes, it will make right edges, left edges, nicely balanced, things like that. And there is a certain basic page format in, which will put the page number in the middle on the bottom and things like that without you having to do these things. But it's still not really a full layout thing. But this is just a plain macros. Other macro packages have been written, and there's a macro package called Latex. Latex because it's written by Leslie Lamport, so probably it should be Latex from Lamport. I don't know how they pronounce it, Latex or Latex, whatever. And that's a macro package written on top of text. And this implements the layouting. It can lay out a letter, it can lay out a book, or an article, or a technical manual, or a lot of things. And based on top of LaTeX, hundreds of other modules have been written. One of the very good and used very much in industry is called Lidifont, and it's made to typeset musical score. And there is no commercial program which does it better. There are almost no other commercial programs in that world, because everyone will use Lidifont. It is so very good. It is has become the standard. So you can do a lot of things, but always build on top of tech, plain tech, LaTeX. So it's a whole structure of modules, and really makes it very easy. All you need is a text file with the content of your document. That's all you need, and a few commands to structure the document. It's a bit like HTML, which is all about structuring your text, and CSS, which is about how it does look. Of course, most web pages get it totally wrong and start using HTML to format the document, which is wrong, but okay. you don't see that it's wrong on the screen, but internally it's totally wrong. Well, with Latex, it is very much so that the commands you use are structural commands, like this. You start by saying what you're going to make. In this case, you're going to make a book. So the document class is a book. You have book, article, letter, and all the things. And then you say, now the document begins. Because between document class and begin, you can upload other packages if necessary, but just to keep it simple, we get that here. And between begin document, line 2, and end document, it's our document, which can be a book, a letter, whatever. And I say we'll start with the table of contents. That's always easy, but you know what will follow. And then we start with the chapter. So chapter between the curly brackets, it's the name of the chapter. See, we don't add the number of the chapter and things like that. This is the chapter title. Of course, everything which follows the chapter title will be the text in that chapter. Until, well, I got the standard lorem ipsum dolor sit amet text, repeat it as many times as you like. A new paragraph will start after an empty line. So if you have one space or 1,000 spaces, or even an end of line sign, it's the same. Only an empty line means a new paragraph will start, which is quite easy. And then we have a second chapter, and again, and we stop with end document. And then we throw that to the text and Latex compiler, and out comes, in this case, for instance, a PDF file, or a DVI file. The original format was DVI, which was a device-independent file, which then could be rendered either on the screen or on the printer or on whatever. So you have this device-independent thing, which you would have to give to a drive to produce a hard copy or a screen copy. But nowadays, almost everyone uses PDF as a final format, and you can produce it directly. Let's see if I have. Yes, it looks like this. This is the page of the table of contents, which are automatically made. Notice that you get contents on top of the page of contents, first chapter, second chapter, page numbers, everything automatically there. Second page is empty because it's a very small table of contents, and this page is empty because a chapter always has to start on the right-hand side of your book. So automatically the empty page is empty, the back side of your first page. This is for two-sided printing, which you always should use, of course, for ecological reasons and to minimize your carbon footprint. Yes? Yes. And you see how it follows. In the standard format, a chapter is named chapter, and then you've got a chapter number. But you can use both packages, or you can give commands to have it differently, either with graphics and things like that. But this is just standard. Uploaded no specific packages, and immediately we get a nice page layout. Every paragraph, except the first paragraph, starts with a little empty space, because we do not have extra space between the paragraphs, which, for instance, Word does. It's ugly, and it's not good. Because if you happen to have a line which stops at the end of the page with a full stop, you don't know if the next page is a new paragraph or not. Because it all starts like in the first paragraph. So you don't know it if you have between paragraphs extra room. And this extra room is lost. The cue, this is a new paragraph, is by having this little indent. That's the way it's normally done. But you don't have to think about it. Latex does it for you. Now we have the next. Look, first, on the first page of a chapter, the page number is on the bottom. On the second page of a chapter, it's on the top left, which is the left page. Always have the page numbers on the outside.